Properties of definite integrals. Let f and g be integrable functions on an interval that contains a, b, and c. We call the definite integral from a to b of the function f of x dx is the net area of the region bounded by the function from point A to point B. The first property, the definite integral from A to A, that means lower limit and upper limit are the same, or the left and the right bound are the same. The net area will be 0. That means the definite integral from A to A of the function will be 0. Second property, the definite integral from b to a of the function f of x with respect to x is negative definite integral from a to b of the function fx with respect to x. The other way we can say if we swap the lower limit and upper limit, we can apply the negative sign to the definite integral. Property number 3. The definite integral from a to b of the sum of the two functions with respect to x is the sum of the two definite integrals. Property number 4. The definite integral from a to b of the constant multiple function f of x with respect to x is the constant multiple the definite integral from a to b of the function f of x with respect to x for any constant c. Property number 5. The definite integral from a to b of the function f of x with respect to x is the sum of the definite integral from a to c and c to b, as can be explained in the real number line. The left end is a, the right end is b, and c is somewhere in between, and you find the area bounded by this function curve. If the total area is separated into two portions, that means the total area as overall is the sum of the first area and the second area, and the first area is bounded from A to C. Second area is bounded from C to B. Property number 6. The function absolute value of the f is integrable on the closed interval, and the definite integral from a to b of the absolute value of the function with respect to x is the sum of the areas, or we can say this is the total area of the regions bounded by the graph of the function f and the x-axis on the closed interval. And it can be explained by using the graph that has the function both in the negative area and positive negative function value and positive function value. For example, f of x equals the sine x from negative pi to positive pi. From negative pi to 0, the area is negative. From 0 to pi, it's going to be positive area. The definite integral from negative pi to positive pi of the sine x with respect to x will give the net area. But the integral from negative pi to pi of the absolute value of sine x with respect to x gonna give the total area. So that means the negative part will become positive part and then added by the other part. So gonna be representing as the total area of the graph. Examples. Suppose the definite integral from 0 to 2 of the function f with respect to x equals 6. The definite integral from 2 to 5 of the function f of x with respect to x equals negative 8. And the definite integral from 2 to 5 of the function g with respect to x equals 1. We're going to evaluate the following integrals. The first part, the definite integral from 0 to 2 of 3 times f of x. This problem, we're going to apply the constant multiple property. It becomes 3 multiplied by the definite integral from 0 to 2 of the function f of x with respect to x. And from given information, the definite integral from 0 to 2 of the function f equals 6. So that means we have 3 multiplied by 6 or 18 as a result of part A. In part B, we have definite integral of the gx minus 5 fx with respect to x. We can apply a couple properties to this problem. as we see the difference, we can separate into the difference of the two definite integral. And then apply the constant multiple property to the second integral. Becomes negative 5 integral 2 to the upper limit 5 of the function f of x with respect to x, and then use the values provided by the problem. For the definite integral of the function g from 2 to 5, it's equal to 1. So this part equals 1. And the definite integral from 2 to 5 of the function f is negative 8. Then simplify the number to be 1 minus 5 multiplied by negative 8, or 41. In part C, we have the definite integral from 5 to 2 of the sum of the fx and 2 of the gx. So we can apply the integral of the sum as the sum of the two integrals. And also the lower limit, upper limit are not in the appropriate order. So we are going to swap lower limit and upper limit and also apply the sum of the definite integral property. And this will give us negative of the whole sum as a definite integral from 2 to 5 of the function f with respect to x minus plus 2 times the definite integral from 2 to 5 of the function gx with respect to x, as we take the negative side out of the entire group. Then we get negative. The definite integral from 2 to 5 of the function f is negative 8 plus 2 times the definite integral from 2 to 5 of the function g, which is 1. Now we get negative of negative 6 or positive 6 as a result. And the last part, the definite integral of the absolute value of the function f of x dx. The provided information is the definite integral of the function f equals negative 8 that represents the net area. That means the majority of the area is below, or the entire area from 2 to 5 is negative inside. This is all information that we have. So we're going to apply the absolute value to the net area that provided. So then the result gonna be 8. Another example, the graph is provided. This is the graph of y equals x times sine x. As we see, 4 separate regions from 0 to pi over 2, from pi over 2 to pi, from pi to 3 pi over 2, and from 3 pi over 2 to 2 pi as the region R1, R2, R3, R4 respectively. And the value of the area also provided as area R1 is 1, area R2 is pi minus 1, area R3, which is below or underneath the x, is pi plus 1, and the R4, which is the area underneath the x-axis also, is 2 pi minus 1. The value pi plus 1 is positive. The value of 2 pi minus 1, that's positive as well. But if you are looking for the net area, which is the definite integral, you have to consider the area below or above the x-axis. The above remain as positive. The one below gonna be negative inside. In this problem, we are going to use the graph or information provided to evaluate the definite integral from pi over 2 to 2 pi. So from pi over 2 to 2 pi, gonna be 3 regions combined. As we recall, the definite integral is the net area. So then the first part, the R2 remain positive, the R3 is negative, R4 is negative. So we get the result as R2 minus R3 minus R4. And R2 is given to be pi minus 1 subtracted by the R3, which is pi plus 1, minus the R4, which is 2 pi minus 1. And then simplify it to be pi minus 1 minus pi minus 1 minus 2 pi plus 1. Cancel some terms. So we get the net area as negative 1 minus 2 pi as the definite integral from pi over 2 to 2 pi of x sine x function with respect to x. From the picture, you can see the R3 and R4. They are majority comparing to the area R2. So the majority of the area is in the negative side area. So then the net area from pi over 2 to pi will be negative inside.